All right, what would you like for me to go over first? Which one's first? All right, let's take a look at 72 here. On this one, what does it mean to solve for a variable? Find the value of it, okay? And as a practical matter, the way to find the value of it, don't you have the variable on one side of your equation and then the number on the other? So if we're going to solve for y, we need to get y by itself. If I'm going to get y by itself, I need to subtract 3x from both sides. 3x minus 3x is 0. Bring down the y. And now, I could write 5 minus 3x, but do y'all recognize what kind of an equation you're dealing with? If you graph that equation, what do you get? You get a line. So with a linear equation, don't we tend to write them in this form? Where'd the 5x come from? So that it fits the y equals mx plus b, the slope-intercept form. So let's do that. So all you're doing really is you're putting these equations, these linear equations, into slope-intercept form. You did this last year, didn't you? Okay, I thought you did. All right. So look at 72 then, or 73 then. First, let's get the y term by itself. So we subtract 4x from both sides. So we'll get 2y equals negative 4x plus 6. And now we're going to divide both sides by 2. But we got to be a little careful here, all right? We're going to say we're dividing both sides by 2. We're going to divide both sides by 2. But the problem I have with it is I'm afraid that you'll do this. Why isn't that correct? I didn't divide the 6 by 2. There's not a distributive property of division, but that's what we got to do. So we're going to say we're dividing by 2, and that is what we're doing. But the justification for dividing every term by 2 is using the distributive property and multiplying by 1/2. Because isn't multiplying by 1/2 the exact same thing as dividing by 2? So now we distribute it, and we get the y, and we get negative 2x, and we get 3. And that's our answer. Does that make sense? All right, then we look at 74. All right, let's start off. On the other two, I subtracted the x term. What do I need to do on 74? Yeah, I need to add 3x to both sides. So that'll give me 4y equals 3x plus 5. And now I divide both sides by 4, but I got to distribute it. So if I divide that 3x by 4, or better yet, think of it as multiplying by 1/4. What's 3 times 1/4? Yeah, so that'd be 3/4 x. And what's 5 times 1/4? 5/4. Now, the nice thing about these, by putting them into slope-intercept form, just by looking at this, what's the slope of that line? It's negative 3. Once you've solved it for y, whatever the coefficient of x is the slope of the line. So what's the slope of this one? Negative 2. Slope of this one? 3/4. Now, the other number is significant as well. That's called the y-intercept. Tell me what a y-intercept is. It's where it crosses the y-axis. Think of the x-axis and the y-axis each as being a number line. So you've got the y-axis here. It's a number line. So this line crosses it at, well, let's see, like that 0, 1, 2, 3, 4, 5. So it crosses it at 5. If we know a point that's on the line, we can graph the line if we know the slope. The slope's -3, same thing as -3 over 1, so I go 1 to the right, 1, 2, 3 down. I've graphed the line. That's where we're heading with this. You did this last year, am I correct? Okay. All right, so for now, we okay with solving these for y? All right. What else would you like for me to go over with you? 58 and 61. Here's 61. It says the area of a circle is 20 pi square centimeters. What is its circumference? All right. What's the formula for the area of a circle? It's pi r squared. What's the formula for the circumference of a circle? So here's what we're going to do. They tell us that the area is 20 pi square centimeters, so we're going to use that information to solve for r. Once we know what r is, we can find the circumference. So if the area is 20 pi, replace the capital A in our formula with 20 pi. And there's only one unknown in that equation now, and it's r. Because pi is not an unknown, is it? Pi is a number. It's an irrational number, but it's a number. So we can solve this for r, at least theoretically. First thing I'm going to do is divide both sides by pi and get r squared on the right. Pi divided by pi is 1. I get 20 on the left. Now, I'm close. I want to know what r equals, though, not r squared. What do I do to both sides now? Take the square root of both sides, okay? The square root of r squared is r. I mean, it makes sense, right? Square roots and squares, they're inverse operations. They undo each other. But I got to take the square root of the other side, and for the time being, let's just call it the square root of 20. That's not what our book's going to call it, okay? They're going to put it in simplest radical form. We're not going to mess with simplest radical form right now. So we'll call it the square root of 20. So now that we know what r equals, we can find the circumference. So we go to our circumference formula, circumference equals, and by the way, if our area was given to us in square centimeters, now that we have r, what would the unit be on that? Centimeters. If the area is in square centimeters, then the linear measure must have been centimeters. So let me squeeze that in there. Okay, so back to circumference. So that'll be 2 times pi times the square root of 20. And you know what? Since we're not going to put it in simplest radical form, that's as good a way to write the answer as any. I might not need the parentheses. Just call it 2 pi times the square root of 20 centimeters. Now, we then look at our answer choices. And we don't have the answer, any of them. Okay? That doesn't mean we've done anything wrong. It just means that they've put their answer in simplest radical form, and you don't know how to do that. Does that mean that you have to guess? Some of you are saying yes. Now, what can you do? Plug it in to your calculator. All right? So let's see. 2 pi times the square root of 20 is 28 point that. Okay? So let's see if any of these other answers match that. So let's try A. It's going to be easier for me on my calculator if I punch in the pi first times the square root of 5. All right, that's not it. Then on the next one, I'll punch in the pi first times 2 times the square root of 5. That's not it. Then I'll try C. I'll type in the pi first times 4 times the square root of 5. And there we go. Oops. There's our answer. All right. 61 makes sense? Yeah. And let's see, 58. The graph of which equation passes through -3, -2, and is perpendicular to the graph of y equals 3/4 x plus 8. All right, let's eliminate a couple of possibilities first. What's the slope of this line? 3/4. So, what's the slope of any line that's perpendicular to it? Yeah, it's the opposite reciprocal. It's -4/3. So, which two answers can we eliminate right now? Yep, it can't be those because they're not perpendicular to that line they told us. Okay? So, it's either A or it's B. How do we decide which one? We could graph it, but if they don't give me a grid to use and I'm kind of off, I do like this. Okay, I'm not too sure my graph would be good. What else can we do? All right. Well, this is called slope-intercept form. All of these equations are in slope-intercept form. How about if we took this equation and those coordinates mean something. One of them's the x and one of them's the y. So let's try putting in a -2 for y and a -3 for x. And let's see if we get a true statement. Okay? Because if you recall again from last year, when you're working with linear equations, the points that are on the line, let me rephrase that, the coordinates of the points that are on the line are solutions to the linear equation. So we're trying to see whether or not that point is a solution to equation A. Okay? So let's see if it is. That'd be -2. Negative times negative is positive. Those divide out. So I'd get +4 minus 6. Does -2 equal -2? Yeah. So I'm thinking that's the answer. But some of you are looking a little iffy. You're thinking maybe I'm doing some kind of voodoo math up here. So let's see what happens if I try plugging in that point into that other equation. So equation B is y equals -4/3 x plus 5. Let's put the -2 in for y. Let's put the -3 in for x. And let's see what happens. I get -2 over here. Negative times negative is positive. The 3's divide out. I get a 4 plus 5. So I'm saying that -2 equals 9. And that's not true. So that means that the point -3, -2 is not a solution of that equation. So we were right. The answer is A. All right, makes sense? Okay, good. What else would you like for me to go over from page 190? Any others? All right. We didn't have a chance to go over the assignment from section 3.2 on page 181. So see if there are any of these you want to go over. Kevin? Yeah. Number 38. Our hint is to draw an auxiliary line. So what I'm going to do is I'm going to draw a line that's parallel to those other two. And they should have marked that those two are parallel. So that's a mistake on the book's part. We need to know those are parallel, or the rest of what I'm going to do is not going to work. So don't assume they're parallel. The book made a mistake not telling you that they're parallel. Okay? So they're parallel, and then I made that other line parallel to them. Okay? So now that I have parallel lines, I can use the corresponding angles postulate, the alternate interior angles theorem, the alternate exterior angles theorem, the consecutive interior angles theorem. So I'm going to do this. All right, right here. Let's ignore that 72 for a moment. If this is 50, what's the measure of that angle that I just marked out the 72? 50. Corresponding angles postulate, correct? Now, that 72 was actually representing this whole angle right here. So if we know that this part down here is 50 of it, what's the measure of that part right there? Got to be 22. Okay? So now, look what's going on here. I've got these two parallel lines. I've got that transversal. If that angle right there I just labeled 22 really is 22, what does x equal? 22. Corresponding angles postulate again. So x equals 22. Maybe. Oh, come on. Now that I've shown you how to do that, how hard is that? They told us to. Oh, yeah. I mean, the hard part's figuring out where to put it. I just showed you. I'm a genius. Because I've done geometry before. See, this is me teaching you. That's how you do it. Yep. So look, let's look at 39. We're going to want an auxiliary line. Where are we going to put the auxiliary line? Right through the vertex of that other angle. Yeah, if you'd have looked it up, I bet you could have found an example of it. Yeah. That was too much effort, though, right? Yeah. So, let's look at this part of it right here. Again, the book did make a mistake not telling us that, that these are parallel. So, that's their fault. All right. If that's 105, can I figure out the measure of that angle right there? All right, because if that's 105, vertical angles theorem says that's 105. So what's the measure of that missing part there? So that's 75. Okay? If this is 125, according to the vertical angles theorem, this is 125. So what's this missing part right here? So, doesn't that mean that x is 75 plus 55? And what is 75 plus 55? So, 130. So, x equals 130. So, you're right. I hadn't already told you how to do that. I tried to get you to figure it out on your own. But now that I've shown you how to do that, not that bad, is it? Now, throughout the year, we will have auxiliary lines, on different kinds of figures. They'll come in handy, especially when we're doing quadrilaterals. Quite often, we'll need to draw in some auxiliary lines. So you put them where you need them. I mean, there are lines everywhere, right? So you put in the ones you need. Since we're dealing with parallel lines, making a line parallel to the others is what seems to make sense. Okay? Now that you know you can do it. So does that help on those? So now you're kind of hoping there's 7 or 8 of those on the next quiz? No? All right. No more than 6 then. No more than 6. That's a promise. All right, what else? 27. All right, on 27. Let's see here. Let's extend some lines. If I do that, and that, and that, and I'm going to stop it. Ignore all the rest of that. Can I find x now? Yeah, it's not even difficult. I've got two parallel lines cut by a transversal. 96 and 2x form a pair of consecutive interior angles. So consecutive interior angles are supplementary. So 2x plus 96 equals 180. Right? You've got to know those theorems and that postulate. I mean, they've got to just be second nature. Okay? So what's 180 minus 96? And what's 84 divided by 2? All right. Now, I'm going to look at this. We have, again, the two parallel lines, a new transversal. Those two angles form a pair of consecutive interior angles, so they're supplementary. So 3y plus 44 plus 94 equals 180. Let's see, so 3y, 94 plus 44, that'll be 8. 138 equals 180. So now what do I do? And 150 minus 138 equals, and 42 divided by 3 equals, and there we go. All right, what else would you like for me to go over with you? 48. A farmer raises chickens and pigs. Oh, no. This always feels like it's more of a joke than it is a math problem, doesn't it? If his animals have a total of 120 heads and a total of 300 feet, how many chickens does the farmer have? So let's see here. All right. Okay, yeah, it's multiple choice. I don't even have a clue how to go about this. What should I do? All right, so there's 120 total animals. No? Say it again? I'm assuming so. I mean, we do know there's 120 animals, don't we? All right. We're assuming each animal has one head. I know, big assumption. All right, so what can we do with this? I can do X and Y, but here's a problem with X and Y. Well, if I have an X and a Y, don't I have kind of a sliding scale? So if I have an X and a Y, the graph's going to look like that, or that, or that. And there's an infinite number of solutions for that. Well, I do know there's 120 of them, though. How many feet does a chicken have? How many feet does a pig have? Let's see. If I let let's see. Yeah, can I do this? Can I say that 2x, can I say that x equals the number of chickens. And so 2x would be the number of chicken feet. And 4x would be the number of pig feet. Yeah. Yeah. Okay. I still don't want an X and a Y, though. I really don't. I may have to get it, but I don't want it.
You can still do that. Like, you know, this chicken.
Okay, you're right. I am going to have an X and a Y. All right, so X is going to be the number of chickens. I was being dense here for a minute. And Y is going to be...
Sophomores need to report to the cafeteria, and also at this time, any teacher who has sophomore classes also report to the cafeteria.
All right, now I'm on the right track, okay? I'm going to have to get a system of equations. If X is the number of chickens and Y is the number of pigs, then X plus Y equals 120, doesn't it? Okay? So, 2X is going to be the number of chicken feet. 4Y is going to be the number of pig feet. So 2x plus 4y equals 300. Okay, I'm in business now. I've floundered for a while, but I got it figured out. You with me? All right. Now, there's a couple different ways we can go about solving a system of equations. One way, called substitution, will be the easiest way here. If I take equation 1, I can solve that for y and get y equals 120 minus x. And then I can substitute into equation 2, 2x plus 4. And instead of putting y, guess what I can put in for y? 120 minus x, because that's what y equals. Equals 300. And this is what I was after the whole time. One equation with one variable. So now I can solve it for the number of chickens. Okay? So 2x plus, what's 120 times 4? 480 minus 4x equals 300. So that'd be negative 2x plus 480 equals 300. So negative 2x will equal negative 180. I don't have negative chickens because now I divide both sides by negative 2. And how many chickens do I have? All right, so have y'all solved systems of equations before? Okay, good. I wish I'd have thought of that sooner, because that's not that bad of a problem if I just think of it the right way. All right. Any others you need to go over? Going once. Twice.